Alright, so I'm going to make a little kind of review or how-to of a camera stabilizer that I've made here. I based my idea largely on this is the finished product here. So I based my idea sort of on the Merlin style idea, but also took a lot of influence from, I guess it's called the Blackbird, I think, where it has this adjustable height to the weights with a rod after the curve. So it's sort of designed to be a hybrid of the best elements of what I saw in some different stabilizers. So I'm going to give you kind of an overview of the decisions I made and how to choose it for, like, either your style or what design elements to use if you're going to try to make your own camera stabilizer and not just follow the designs you see on the internet, because there's pretty limited information on how to design it as far as the principles behind it. How does it work? What do the different pieces do as far as changing how the performance of it is? And then I'm going to show you some sample footage, of course. You can see what kind of difference it makes, how it works, compared to not having one. And it certainly has been effective for me. I've only been using it for a little while, and it's true that it is a skill. When you're learning to use it, you need to practice. And the first time I picked it up, it worked okay, but I'm getting better at it. I'm a long way from being a master at it, though. So let's just get started here. So the first thing you'll notice is it's made out of aluminum. I started with an aluminum flat, like a lot of designs are out there. My aluminum flat that I chose is 2 inches wide, which is wider than most that people have out there, and the thickness is 3/16 of an inch. So what's commonly available in most like hardware stores and things is like an 1/8 of an inch thick, which is, my opinion, too flexible. And from what I've seen other people talking about their designs, if you have anything more than a very light camera like a GoPro or something, then what's going to happen is it's just going to flex too much. When you move, when you walk around, once you put weight on the bottom here, it's just going to wobble, and that's what you're going to get in your camera video when it comes out. So I wanted to pick something that was thicker, and when I went there and I kind of tried to bend the different flats that I could find, this is the one that I liked how it felt without being too thick. 1/4 of an inch was, it seemed like it would never be able to be bent by hand. So I just couldn't go for it. I thought 3/16 of an inch, I can probably bend that, and so that's what I chose, and it's worked out pretty well for me. So the curve was just sort of eyeballed, but this idea here came from several other designs. If you've been looking at stabilizer designs that are DIY on the internet, I just wanted to do something similar to that, where you have your gimbal set up underneath here, and it has something that makes it adjustable front to back, and then a separate stage for your camera. So I chose this diameter between here based on actually the available. I wanted these little adjustable turn handles. I have one here, and then one goes into my camera when it's on there like that, and I'll give you a shot of my camera here in a couple of minutes. But to be able to accommodate the height of both these handles, I chose 2 inches in here, and it came out a little bit larger than that, but it worked out pretty well. So in general, some of the pieces I have on here is, you can see I have on the bottom a weight supporting sort of a, I don't know, a strut, whatever you want to call it. I have in here a slot cut out so that I can move this forward and backward based on how much weight is on the top and where that weight is at. And then obviously I've got washers here. These are 1.5 inch washers with 5/16 holes in them. That was the 5/16 hole ended up coming from that was the smallest hole I could find through the center of the inner diameter to get a large washer, like a 1.5 inch washer. And these things are kind of expensive. I was a little surprised. The first ones I got were at the Lowe's. They were like $7 or something for 25 washers, which seemed outrageous to me. I ended up getting them on Amazon for about $4, like $4.25 for 25 washers, and so I've here used about 30 or 32 washers, I think, is what I've kind of settled on. So you need quite a few if you have a camera of similar size like mine, my video camera weighs a little over 2 pounds with the microphone on it and the battery. So you probably would need something similar to that if you're making a camera. This is what I found is the most suitable weight for the drop time and in this design. So one thing you'll notice that I've kind of, I guess, skipped over a little bit up to this point is my gimbal design. This is something that for me I wanted to do differently than any of the other designs that I saw on the internet right away, because the first thing I saw or read about with all designs is that, man, you're going to spend a lot of time, even the professional ones, like the ones that cost, you know, like the Blackbird or whatever it is, costs like $500, you know, the Glidecam, things like that. This seems like you spend a lot of time balancing this thing and getting it right, and then you know, just the slightest little whatever adjustment, shift change, you know, you take the lens cap off, you know, if you've balanced it with the lens cap on, bam, it's way out of balance all of a sudden. So I wanted something that was a little bit easier to balance, and those designs that use the simple universal joint seem like people had a lot more difficulty balancing those, because it was really, I mean, it was described like, hey, you're basically balancing it on the head of a pin. It was such a small gimbal, and so it gives you limited flexibility as far as movement as well, because that ball has to go into a, you know, kind of a socket that holds it, and so you have that limited a little bit of movement, and then the balancing of it didn't sound good. So I said, okay, how am I going to design it so that I can get better balancing? It seemed like the gimbal designs that are used in these glide cams, people had an easier time balancing them. And those ones are based on bearings and had a little bit more size, a little bit more diameter. And so I thought, well, how can I incorporate the gimbal type design into the Merlin style, because it doesn't have that center post, right? A lot of people use a skate wheel to hold their bearings that do the rotation kind of axis movement. And so I didn't want to do that because cables are kind of heavy, number one. But I thought I could be more creative too with the way I did it. So what I ended up with, I'm going to move in a little bit here. So what I ended up with was a T-joint here, a T-joint in the middle. So I have in here 2 vertical bearings, and I can actually pull this out. Maybe not. There we go. Woo! I can actually pull this out. So I basically have a 5/16 inch bolt here, and this goes through 2 bearings. There's a washer in the middle, and there's a nut on either end to hold them together and make sure they work as one piece. So I chose 5/16 bolt based on the inner diameter of my bearings. I bought some bearings that are a little bit smaller than the skate bearings that most people use, actually as a mistake, but I ended up really liking it and being glad that I picked that because they're a little bit smaller, and so I was able to make my gimbal design a little bit smaller. These are 19 millimeters on the outside and 8 millimeters in the inner diameter, and so a 5/16 inch bolt is basically the same size as an 8 millimeter one. It's not exact, but it works well. And to make it fit real tight, I put some plumber's tape, which is it's like a very, very thin plastic tape. I wrapped it around the bolt a bunch of times and then slid those bearings onto it. And what it does is it makes sure that they're exactly the same position relative to each other on the bolt, and it keeps them from doing any kind of wobble because they're secured there. So that's where I started. I said, okay, I'm going to have 2 vertical bearings that'll give me my rotation, and they're going to work together to hold the weight. And so because of having 2, it doesn't give me any kind of shearing type bending motion, it makes it stronger. So the next thing that happened is I had a T-joint, right? These are a little bit funky because they're 3/4 of an inch, but if you guys have been working at all with plumbing, then, which most people haven't, you know that 3/4 of an inch, 19 millimeters, has nothing to do with 3/4 inch pipe. So a 3/4 inch pipe is not 3/4 of an inch on the outside, and it's not 3/4 of an inch on the inside either. So you can't use a coupler, you can't use the pipe itself. That's why skate bearings work really easily, because that, what is it? It's 3/4 inch pipe, but it's a special kind. I can't remember. There's a lot of videos that'll tell you. It's like a different color and everything. But the inner diameter is a little bit different than standard 3/4 inch pipe, and so that skate bearing works perfect. So for me, because I had a 3/4 inch bearing, I actually had someone I know, one of the guys that I work with, has a 3D printer, so he actually 3D printed me this T-joint piece. I don't know if you guys can see that, but it has little striations kind of in it from the layers coming onto it. And so he printed this up for me, exactly what I wanted, exactly what size, and it took us a couple of tries, but it was only like $1 and change worth of materials or whatever to make it. So he didn't mind printing me a few, and I had to do a little minor, hand sanding to get it perfect. But once I did, then this guy just slips right in here perfect. I wouldn't hold it upside down, but it certainly stays in. You can see I don't have to worry about it. It doesn't wiggle or anything. The next step was I put in a bearing at each end, as you might have assumed. That's why there's a T-joint. And then I wrapped those bolts with, it's actually one bolt that goes all the way through here with pipe tape to make those bearings, secure as well, just like the vertical bearings. And then there's a nut on either end of it. And what that does is it holds the bolt centered, so it can't move back and forth, and it keeps any wiggle out of it, and actually holds the bearings in. None of these bearings are glued in; they're just pressed in there with friction or the pressure from these nuts. I didn't want to be able to have it so I could never take it apart and replace something if I needed to, and so that was part of my design as well. So these two nuts will pinch it in to make it work. This white ring here is PVC. It's a coupler, so it's a 2-inch coupler, which isn't actually 2 inches across on the inside or the outside again, but it's called the 2-inch coupler. And so I just cut a section that I needed, and in a drill press drilled some holes straight through, 1, 2, so it's coaxial. I could just run that bolt straight through it, and I used a carriage bolt. You can see on this end it has a round piece, so I had to go in and cut out a little bit into a square shape to accommodate that inner part of the head on a carriage bolt. But then the other end you can just throw a nut on there, and with those nuts in the middle, holds it all together. It can't move around. It's perfect. Now I have sort of a cutout here. You can see that, I hope. There's a little bit of cutout in there. So I thought originally, man, what I'm really going to want to do is be able to move all the way up here, move it all the way up here. It'll give me lots of range of motion, so I need that cutout to accommodate it, right? I don't know why I did that. I realized once I put it together that the difference between this and this is not really worthwhile. So I would, if I was going to do it again, and I may, make this piece narrower, and then forget that, just make this axis for these 2 bolts down here. These are 2 bolts. This is 1 bolt up here that goes through the white and through the T-joint. So I would move this up, but I think it would make it even a little bit easier to balance too, because right now I have one axis here. This axis that does this is lower than the one that's up here that does this, and so I'm not sure how much of a problem it makes because I haven't built it the other way, but it's not too hard to balance, which is, I'm kind of liking it. The first time I had to balance it took forever to kind of get the idea, but once you have the general idea of where they should be, it's like super quick. So the next step, so I cut this PVC section out of a 2-inch coupler, I drilled the holes, put that bolt through it through my T. Then the next thing I drilled 2 more holes for this bolt and this bolt in the sides. It's exactly 90 degrees to the bolt that does through the T-joint, and you can do that in a drill press just with a long bit, because this is only a couple inches thick. As long as you get it at the highest point, when you hold it under there, and you'd be good idea to hold it down with a vise, because otherwise it could jump on you or whatever. But it's easy to cut through PVC, so that makes it a little less difficult. But anyway, so you go through there, you get your one on the perpendicular. Now I have something to go through. So what did I do with this then? So in here, hopefully you can see this, I have 2 screws. So one is here, it goes out, and another one is here, it goes out. These are actually 8mm ones, because this is the easiest length that I was able to find. So this one is 5/16. This bolt is 5/16 because 5/16 is common in America here as a width. 8mm is harder to find, but this worked out better for me because the length was already there, and I didn't have to buy a longer one and cut it down. Plus they're actually the right size for these bearings, so I didn't worry about it. So I put that screw through, in from the outside, or out from the inside I should say. Put 2 washers in there to get the right spacing, and then a nut, so that holds it centered, everything, and then I kind of make a sandwich. So I have, this is another PVC coupling, this black piece. I just chose a different color because that's what they had. I thought it looked smart. So I cut out the first thing I did was I cut a section of it so it was around a circle. And then I had to go and get something that was the size of my bearings. So again, 19 millimeters are very close to 3/4 of an inch. So I was able to find a stepped bit, and I was able to get that at Harbor Freight, pretty cheap. It was like $6, and you can use a coupon if you want. It's a stepped bit, has like 6 or 7. Looks kind of like a pyramid, a step pyramid, where it drops out in layers. And so the largest diameter of the bit was 3/4 of an inch. And stepped bits make real smooth holes. Not a lot of mess, and so that's kind of ideal if you're trying to make a nice bearing size perfect hole, is to use a stepped bit. So that worked out good. They have a 3/4 inch one, so you can just throw this thing on your drill press as a ring, drill your hole through it 3/4 of an inch, flip it over, make sure you're straight across from it. If you have a really long bit, you can drill a pilot hole all the way through first, which is what I did. Drill a pilot hole all the way through, and then you know for sure that they're going to be directly across from each other. And then I drilled the 3/4 inch hole on one side, then flipped it over, drilled the 3/4 inch hole on the other side. They came out great. And then after I had those holes in there, then I went through and cut it into this half circle. I just used a chop saw, and it was real easy. And that was how I made these sections too out of the pipe. So when I cut the long 2-inch coupling to a shorter section like this, that's what I use as a chop saw. And the same thing with the black one, and then to make it into a ring. Boy, this feels like it's really wordy, but I'm trying to give people the skinny on how I did this and some ideas on how to, and this is definitely the part that's the most involved and the most original on the design, so I'm trying to give you lots of information. So I got those bearings. It was 3/4 of an inch hole. They're 19 millimeters, which is just slightly smaller, which just made it perfect for me to just brush a little super glue around the outside of it and slide it in there. Once I had them in, I actually put the whole thing together beforehand to test it. And so what I did was, holy moly, that's loose. Oh, okay. Anyway, I put the whole thing together beforehand and was ready to go. So what I did is I practiced assembling it. And so once I had the super glue on there, I just had done it before. I was ready to throw it together because it dries quick. And once you get that bearing in there and leave it there for a few seconds to get the other one in there and put the thing together and make sure when it tightens down it's exactly where it should be. Pardon me. You better be ready to do it quick, because like for mine, I even probably would have done a little move to just a little bit more over to the other side. But I mean, the way it works is fine. But I had to work quick, and I was ready to work quick, and it still beat me a little bit because when I super glued them in, that was it. They're ready to sit down because that hole is already pretty snug. So once you slide them in there with a little super glue, it dries quick, and it's PVC, so it just grabs right on. Anyway, so what do I got? I've got an 8mm bolt coming out, 2 washers, a nut, a bearing, and then a nut. And it's the same thing on the other side. A screw that goes out from the inside, 2 washers, a nut, bearing, and a nut. And so those washers are super glued in again, and they're just standard nuts here. The ones on the inside that I used, these nuts that are on the inside of the white piece, are actually, what do they call them, jam nuts? I think I'm not sure what they're for, but I used them here and here too around these bearings. They're thinner nuts, and so it allowed you to get in a little bit tighter space and have some room to work with still. Whereas if you used a fat nut, like a standard nut, it would be pretty thick. So just for information out there, all this stuff, all the bolts, all the nuts, PVC, everything else, I got it at just a local hardware store. I chose Lowe's. I'm sure you could get it at another one. But yeah, so anyway, so now I have, with those bearings, I have this rotation up on the top and that nut. And then with the other bearings, I get this rotation. I actually use it this way. So I get this rotation right here, and then the handle circle gives me this. So I got a 3-axis bearing, and then at the bottom, just my handle is, I just drilled a hole, perpendicular hole. This hole is only 1/4 of an inch. I used a 1/4 of an inch aluminum rod, and I used a tap and die set to put some threads on the end, so I could just stick the rod through the hole, put a nut on it, and then there's actually a piece of PVC in this handle. This is just like a standard, I guess, kids bike grip, like a BMX or something. I don't know. I got it. The bike shop gave it to me for free because they only had one, and I only needed one, so I kind of begged it off him. And so I slipped that on my piece of PVC pipe, Then the other end just has a washer and a nut because I threaded this end too of the rod, and it made it as light as I could. I didn't have to add another bolt, which are kind of heavy. And there I had it. So handle, circle gives me 3-axis gimbal. If you guys have any questions on pieces I used or how I made that, I can answer them in comments, but this is kind of what I'm working at. The idea of the positions of all these I'll kind of explain real quick. So the reason why I made this part so that it spins on the very top instead of doing it in the handle is if I'm ever at an angle, it's not going to work right if I get my rotation. If I'm over this way in my gimbal a little bit or this way, then if the rotation is in the handle, it's not going to rotate correctly. I'm not going to be able to spin it smoothly to follow someone like a pan or whatever, or rotate it. It's not going to spin right. So I wanted to do that all the way at the top because then it would always be perpendicular and I can always get a good nice level pan. The other two just kind of worked out of necessity because I was going to have a T-joint to hold that vertical part. Then the next thing either could go this way, so I could do it this way, or this way, so it would go this way. So anyway, so you can get it's just a question then of how do you want it to work. So the reason why I figured that I would put this movement, I don't know what you call it, yaw or tipping or whatever. Anyway, this movement on the bottom or the outermost ring was because I figured it would be easiest to lower it down, like if I'm holding it down low, like to get my daughter, like she's only 2. So if I'm trying to hold it low to go, I thought this would be the easiest to get it low, it'd be this angle. If I had to do it, the rotation, then what I would be getting is I'd be trying to rotate this white piece up forward to backward, and I didn't think I'd get as much movement for rotation, and so I thought this would give me the most flexibility, again with this cutout, which probably wasn't necessary, of movement by going rotation at the top, then this left-right tilt here, the second level, and then the front-back tilt all the way at the outermost ring. So that's kind of the gimbal. And then as it comes through to the top here, so this is just a turn handle. Again, these things are available at your Lowe's or whatever. It just has a nut on the bottom and a little washer. And then the top, it doesn't even need a washer. You just throw that tightening handle on there. This allows you to both move the handle up and down with the threads, right? Because I can adjust essentially the fulcrum point by moving it up and down. And then it also allows me to slide it back and forth by having this tightening handle here. So this is actually adjusted about as high as I can get it. That was kind of where I liked it best. So anyway, that's where I have it. It works good. I liked it high because this gap came out a little bit more than I wanted to, and I have it balanced pretty well, but I think it might be more effective if it was closer to the stage. I'm not really sure, but anyway, this is what I've got. So some of you might be wondering, well, how did he get these bends? These bends are pretty nice. So the way you do it, a lot of people are just bending them in like a vise. I suppose you could use like a block here or something. I just wanted to make it out of one piece. I thought a little bit of flex would be good for taking something out of the steps, like when you take a step and it kind of jolts. I don't know that actually works, but that was kind of the idea. So the way I bent it was I actually went to Harbor Freight again, and they have something called a compact bender. And they have a bench version and a floor version. I haven't decided if I'm going to keep it yet, because I'm going to try to do a railing, do some other things with it, but it was about $70 on sale. Again, they have lots of coupons. $70 is kind of a lot of money for a tool, but it does some really cool stuff. There's scroll attachments, it does all kinds of attachments, different things that it'll do, but one thing it does do really well is bend curves. You get little dies, and you can go online and see what the compact bender does. There's a bunch of videos about it, but essentially it allows you to build smooth curves through metal. It'll bend steel, it'll bend whatever. So I thought, my rule is just in general, if you have the right tool for something, usually the job is easy. If you have the wrong tool, if you're trying to just make it work, it takes 5 times as long and it comes out like a piece of junk. So I just got the right tool. This is the shape I wanted. It gave me this nice bend, plus it made it easy. I just used the 2-inch die here, and then I first used the largest die, which is like I think 4 inches or something, to put in this sort of a gentle curve here a little bit, and then went back. This is the way you want to do it, and then went back and got a 1-inch die right in here real tight, and got it as tight as I could get on both the bending arm, like you can see how to use it online, but there's a stop block. You want to get that as close to that 1-inch die as you can, or any die that you're going to use if you want a precise bend. And then you'll use like a rolling die on the other side, on the actual bending arm that comes around. You want to get those as close as you can to the die size that you want. So that was how I ended up getting this. So this is a 1-inch die. This is the largest die, and I just made several little bends here all the way down, and then one big bend with the 4-inch die on there. So it gave me my nice gentle curve. Going back, I might have made this a little less steep, but it looks nice like this. It's kind of a, I don't know, aesthetic choice, I guess. I did a technical drawing, sort of visualize it before I made this, and this is what my curve looked like in my technical drawing, so I ended up following that. Part of my design, though, is, and I'll show you in a minute, I wanted this height. I chose it specifically because it will fit in my camera backpack. So the whole idea was, I want to be able to take this thing on vacation, I want to be able to take it hiking, wherever I go, and not have to just lug the thing around or strap it to the outside of my bag. It looks weird, right? Like you're carrying this thing around. So I'll show you my bag in a minute, but anyway, that's where I chose the overall height and partly the width, because that's what would fit inside my bag when I take it apart. So the whole thing just goes right in there. It's easy for me. I just have to take off this bottom plate right here and the bolt. So where I'm at. So I've gone over how I kind of did the gimbal and what's involved in there, how I made the bends, this bend here, and then the bottom, the only thing going on here is you can see I've got another bend. That was another 1-inch die, and then this I just left flat. It's parallel to the top, or at least as close as I could get it. You have to make sure that when you put it in the bender that the flat is totally level, and that your arm, you're bending it, is level. Otherwise you get a twist in your metal when you did it, and I got a little bit of a twist at the bottom because I didn't level it quite right when I did the last deal. So alright, so the next point I'm going to make here, I had to jump out, get my backpack here, you can see, so I can show that to you in a second. Next point I'm going to go over is one other thing that I did before I bent the flat. This is important. So on the top here, and in this second level after the bend, and on the bottom you can see I have a slot. So the slot gives me adjustability for my weights moving forward and backward, and then for my camera to go forward and backward, and my gimbal to move forward and backward. So the way I did that, it's not really complicated, but you want to get your drill press out, right? You don't need a especially fancy bit for aluminum, but they can kind of fill up your bit if you have a real small bit, but these are big holes, so you probably don't have to worry about that. So I didn't need a special bit or anything. I just got the sizes right. So on the bottom of most cameras is a 1/4 inch, right? But I didn't want to cut a 1/4 inch hole because then you don't have any adjustability. It's only going to go forward and backward, right? That's not what I wanted. So I figured out that because my center of gravity was only off by a little bit, about 1/8 of an inch, that I would drill my hole 1/8 of an inch off of center, right? Because my center of gravity is off a little bit when I put my screen out on my camcorder. And so let's make that adjustment right away. Then all the range of adjustment that it would have would be around that new center of gravity, right? Because it's always going to have the screen out when I'm using it, otherwise it's useless, and then it gives me my right balance by moving it off to the side a little bit to begin with. So when I did this top hole, what I did is I drilled out a 3/8 of an inch drill hole on the front and the back of where I wanted it to be. I knew how long this was going to be, I knew how long this was going to be, I knew how long the curve was going to be because I can do math, right? I knew this is a 2-inch diameter bend, and I know that diameter times pi is the circumference. I won't have it. You can figure out how to do math, but essentially I knew how long this was going to be, so I measured it all out and where my holes are going to be. I marked them. So this is a little bit off center to match where my weight is going to be, and I drilled 3-inch hole, 3/8 inch hole, and then I cut the slot out from hole to hole by getting in with a wrap file, which if you haven't had a wrap file, they're not very expensive. You buy them in like multi-packs. It's just basically a rod, and it's round, but it's a file all the way around the outside. So I was able to kind of square off that hole a little bit, and then get my jigsaw in there to just cut a straight line, which I used a fence. I don't know that that's really necessary to try to get a straight line. Actually, one of them came out crooked. I think maybe it would work better if I just vicing it down and cutting it by hand personally. But mark your line real careful, mark it, measure it again, and then make sure you're in the right place, and then cut it, right? But you definitely want to use, they have aluminum blades. The blade's not made out of aluminum, but they're made for cutting aluminum. Just invest in some of those for your jigsaw and just whoosh, slide right through. Easy. If you don't use aluminum blades, the aluminum is real soft and it'll kind of fill up the teeth on it, and then it won't work very well. So they're only like $5 or $6. You can buy them on Amazon. Bosch makes them. That's what I use. And so you get your cuts here with your jigsaw from where your drill holes were to make that slot. I did the same thing on the next one, except this one's centered. It's not off-centered, and I used what did I use? 5/16 inch drill bit, because that's how big the bolt is. I didn't really want any adjustability left and right in this one too much. I just wanted to be able to slide back and forward. I wanted that adjustability up here, so I cut it out extra wide so that I would be able to move it back and forth a little bit. And then on the bottom, the same thing. It only moves forward and backward, so I just drilled this one a 1/4 inch hole to match the 1/4 inch bolt that I used down here. So then jigsaw between, and so that makes your slot. Drill, jigsaw in between, and you have an adjustability slot. So it doesn't give me as much adjustability as a lot of the designs on the internet, where you're like, can move it way back and forth with a huge stage, but it's also a heck of a lot smaller and more simple to be able to just loosen the knob, push it over a little bit, tighten the knob up. And when you get to sort of a good point, you can add washers to the bottom, like I did, a little bit more on one side than the other, if that's what you need. You just don't want to have a huge ton of weight on one side and not on the other, because then you get funky dynamic balance like when you spin it. So this works fine for me. I've never had any problems with dynamic balance, so I can tell you that it works. Why it works, I don't know. I'm not an engineer. But the bottom piece is the last piece. It's fairly straightforward. It's just rounded ends, which I did on all of them, again with the jigsaw, and then polished them down with a file. Then I drilled holes 5/16 to hold my bolts to secure my washers, and then a 1/4 inch one in the middle. What I used was a carriage bolt again. This has a rubber washer on it, which I found works pretty good actually to keep this from spinning. So I put a rubber washer in there, and then a big washer, and then another regular washer on the top, and a nut that keeps this bottom part from spinning at all. And then all my tightening and loosening I do with a wing nut and then another turning knob. So I have wing nuts here to take those on and off easy, and this comes off real easy so I can put it in my bag. So boy, I don't know, I feel like this has been going on forever, but that's so much detail as I can give you. I mean, I went in and I polished it with some different sandpapers to kind of go down and get a little bit of the roughness out of it, but it still has some marks because I didn't go back and repolish it after I put it through the bender. So but I don't care, it looks fine to me. So anyway, that's what I ended up with. It works well, I think, better than some of the other designs, again because I went away from the universal joint design, which is simple and is cheaper. This design certainly took me a lot more time to be able to make it, and a lot more care to be able to make it, but I think it probably balances a lot easier because I don't have much trouble balancing this thing at all once I had kind of figured out generally where the weights should be. And it stays balanced. It's usable even if it's not perfectly balanced either. And what you're going to do is you're going to hold it, and you're going to kind of steer it with this little, by just kind of just using your fingers, just lightly touching on this little bolt here, and hardly even touching it at all, just sort of brushing against it to do it, because you'll see things if you try to manhandle it, then it kind of takes away the benefits of having a gimbal. So let me show you some footage, and then I'll come back and I'll show you how it fits in the bag here, and then you'll see, wow, that's amazing, what a good design. He thought ahead on that one. So let's show that footage and we'll be right back with it. Alright, so I'm just walking here, something that you would feel comfortable doing even if you weren't holding the camera, but this is with no stabilizer, so you can see it's pretty rough, rolling shutter, all of it. Then I go into, with the stabilizer set up, it's a little wobbly. It was actually kind of windy on this day. I know it doesn't really look like it, but I was getting a crosswind and it was giving me a little bit of problems with keeping the stabilizer on target and sort of standing up straight, which is sort of a problem with these. wanted to give a side view too, since this is sort of like if you're following somebody, following alongside, trying to get a walking shot, which is kind of common in a film, or for me, I'd like to make it, but you can see it's pretty rough with handheld. And I get that big sway at the beginning here, but then once I start moving and get it stabilized, then it works pretty great. I was actually really surprised at this shot. It came out more stable than I thought it was going to. And that's just with no weird walking or anything funny. Here's a run. It wasn't flat out, but it's basically unwatchable. This is on the stabilizer, and it's a little wobbly again. That's mostly my fault because I'm not very good at this. You can see this. This would be totally useless. You just have to delete this if you were only going to be able to do things handheld. And then with the stabilizer, again, I have that kind of surge at the beginning, but then it stabilizes out. The side carry is actually really stable on this. I'm surprised. All right, so now we're back. Okay, so what I have is, a bag that's made by Lowepro. It's called the 200AW. It's a sport bag. So anyway, what that means is it holds a Camelback up here. You go, the hose comes out, which is great, or the the bladder part of it. And then this isn't a commercial for this or anything, but so what it has is it has the flap top. So I've got buckles here, and then a drawstring, and then just this is like an open bag part on the top here. But then on the bottom, from the side, I can get in and I have a double pouch. So this is set up right now. I can carry my DSLR and my camcorder in here, both, along with the flash and my lens hood. It all fits inside this side pocket, and it's attached to this side. But on this side, it's not attached. It just has a pocket, and the inside of it's open, so you can carry a tripod, or if it fits, or a monopod, which is what I do. But because it's not attached over here, and it's not attached on the bottom, this camera pouch, the bottom of this will actually go right inside like this. It'll fit in the handle, and the top, the stage part, fits above where the camera is going in, and then it goes right down the side, and the flat part fits underneath where the camera is going, because it's not actually attached to the bottom. There's like a rain hood down here that's in a separate pouch, but the padded inside pouch isn't attached to the bottom. There's a little slot underneath it, and so this thing fits right inside. I just have to take this bottom part off, which is easy. I just unscrew it and then drop it in the top with the stage part. And so I can't fit a bunch of other stuff in there with it, but the idea that you can take this whole thing, it fits inside this bag, it doesn't look weird, it doesn't poke out. I can just drop the top over. Once I cinch it down, I've got everything else that I need in the top or in the side, and I'm ready to go. I can go on a trip, I can go on a hike. I've got water, I've got my stabilizer, I've got my DSLR, I got a flash, I got my camcorder and my microphone, and it all fits in one bag. And it kind of weighs a lot by that time. I mean, without water, I weighed it with everything else in there, I get about 13 pounds. So that's kind of heavy, I guess. But to be able to take everything with you in one bag, it works out pretty good. So if you're looking for a solution like that that's really portable, it doesn't have to look like this. You can make a design that's similar, maybe simpler or whatever, and you can get a bag like this, which is kind of cool. I think on its own, it's a good bag. You just pop that in there and you get super portable. So I have some little pads on here. I use some coasters, like 4 coasters for furniture. I had some rubber on the bottom that I didn't use anymore because they were ugly, and so I just I cut the rubber off the bottom because it was glued on, and I just put it in some slots, and now that holds on my camera, so I don't have to worry about getting scratches on the bottom of my camera. And then bam. So the only thing I'm going to add now is just I'm going to print out some rulers from my photo printer and just tape them on there, try to make them look nice so that I have some range that it's marked so that I can go back. Right now I'm just using like painter's tape to show, oh, okay, here's where I had it last time, and so then I can go right back to balancing again. But I'll show you what it looks like with the camcorder on it here now too, and you can kind of see how the whole setup works. Alright, so I'm going to give you a quick look here. I've switched to my DSLR camera to give you an idea of what this looks like with my actual camcorder, the way I'm using it on there. So, as you can see, I really designed it for this this camera because I already bought the camera, and so I knew approximately essentially the width of the base, the width of the camera, and then even I went in to measure, like, okay, where's the center of gravity on this camera when I have the screen out. Okay, so I knew how much off the center it was, and I actually cut my hole off center, so this fits on there just exactly like I wanted it to. When I'm holding it, it's turned out that I didn't bend it quite exactly straight, and so it leans a little bit to the side when it's actually balanced. Oh, of course. With the screen out and the lens cap on, it balances totally differently, of course. So lens cap on? Yes. So now it should be, yeah, just right. So now it balances just fine, and this is just how I run it. I run it with the SE mic on it, and I walk around like this and make it pretend like I'm a real pro or something, right? Anyway, that's what it looks like when you have the camera on it, and how does it stand, and how does it balance. I've done my adjustments. My weights here are a little heavier on one side than the other. I've got some extra weights over here, oops, so that it will balance out for this screen being on the side. I didn't want to move it too far off of the edge to balance it out, but it is actually off center to make sure that the camera isn't weighted too far to the left to where I had to add a ton of weight over here. So anyway, this is how it sort of sets up on the actual, and how proportion wise it looks like on the gimbal. You've seen the sample footage. It obviously works pretty good. It's not perfect, but it's massively better than doing it without anything on it, any kind of stabilizing action on it. So man, I tell you, if you're into taking videos of your kids, at first I felt like kind of a goofball, like even after I spent like a long time planning this out, making it, first, like, I felt like kind of a goof carrying this thing around, but I thought I would get a lot of looks and people would think it was weird. I really don't, which I was kind of surprised at. And the quality of being able to, the freedom of being able to move around, because I just shoot mostly family videos. I said it in my mic review. Being able to move around with your daughter, your kids, whatever, take videos of them that look decent, that's not shaky, that's not crummy looking, that you can keep and have that watchability, that you can really look at it and go, okay, well, it's not perfect, but I made it, and it doesn't look terrible. I could watch it and not be like, ooh, man, I wish that looked better. So it's really valuable to be able to do that kind of a thing, to be able to have something quality. So if you don't have the means to buy a nice stabilizer that costs $500 or $600, and you have some ingenuity and you have some tools, it doesn't really cost that much. Even if you count in, like, I spent about $55, I think, on materials, including the bearings, the aluminum, all the plastic and the bolts, and including buying the drill bit and whatnot. The only thing I don't count in that is the bender, the compact bender, which was like $70. But even if you count that in, you spend $120, which is kind of a lot of money, I guess. But if you consider that now you have some tools that you didn't have before that you can make all kinds of other stuff with, that's not bad. The only thing that I would point people towards if you're buying tools, and I just kind of slipped this in at the end, is that the 2-inch dimension, the width, that compact bender is technically only made to bend 1 5/16 inches, not 2 inches. It says 2 inches on the website. It says 2 inches on the box. Most of them don't fit a 2-inch flat in them. The one that I got is a little bit wider than all the other ones. I don't know why. It was just made that way, but I found one that was a little bit different, and so mine fit right in there. But most of them are not built to, because I did put it in other ones, and it was like, oh, this doesn't fit because it's 1 5/16 inch wide. Stupid. But now I'm sort of rambling. But anyway, so take my design for what it's worth. If you have questions about how I made it, or what's going on here, you can ask me that in the comments and I'll get back to them. I'm not like living on the computer, but I'm pretty responsive. I'm on the internet a lot because my work involves computers. So yeah, I'd say invest your time. Do it because you think it's fun. Do it because you like making videos and having them look good. Um, you know, you can buy those ones off the internet, I guess, for little cameras, for like $50. But honestly, they look kind of janky, and I don't think I'd like them. If I was gonna make another design, I think I'd make it with straight pipes, maybe PVC or something, and do more like a glide cam design just to try it out and see how it worked. But I like this a lot, so I don't know that I would want another design. The only reason why I'd want to try to do it another design is to make it a little bit lighter. Um, this does weigh about 2.5 pounds. This part of it, with the weights that I need to balance my camera out, weighs about 2.5 pounds. Um, I'm sorry, it weighs about 3.5 pounds because my camcorder is a little over 2 pounds with the microphone on it, and the whole thing together weighs about 5.75 pounds, a little less than that. So um, you could hold that thing all day. It's not super heavy, but I mean, maybe if you're a weakling or something, I don't know. But nobody likes to think they're a weakling, right? So yeah, try it out, make your own design. If you want to try to build this, I can point you in the directions of how I did things. Again, if you want to simplify it, unless you know somebody with a 3D printer, work with the standard skate size bearings and find yourself the right size plastic PVC pipe that fits it, because I know that it's out there. Even though I didn't make it, everyone else uses that size, and I'm sure you can do the same thing that I've done here with just a little bit bigger pipe. So the only thing you'd have to do is shorten the T-joint probably to accommodate the narrowness of the bearings and be able to get it inside the coupling. So anyway, hope you found this informative. If you've watched this far, then you probably are bored to death, but you might know a little bit more about making this design, thinking about a bigger gimbal type setup with bearings to give you easier time to balance it, and then the weight on the bottom, you definitely want to go wider like this. I didn't really explain this, but the width, the farther you make these weights apart from the center, the more stable it becomes. That was why I didn't want to just throw weights in the bottom. That adjustable weight design where you kind of have like a swing arm, that seems goofy and stupid. So anyway, I made this. It makes it more stable if you can have these farther apart. It makes it more stable if you have them farther down too. You can actually get a longer bolt, and I have that. I have a longer bolt that if I want to, I can reduce the number of washers, make it weigh less, and have it go farther down. And it still goes in my bag. I just switch this bolt out is all I have to do, but this is more portable, I think, and this is how I've been using it mostly. So those are kind of the ideas, designs. The bottom, supposedly they say that the bottom should be about half the weight of whatever's on the stage. That way the length of it kind of does the balancing of it, because it's going to be farther down than the weight of the camera is above the gimbal. You know, when you balance it out, and my drop time works out when I hold it up like this, it comes out like it's supposed to. It's like between 2 and 3 seconds. That's what you're supposed to have, is when you do your drop time. It goes between 2 and 3 seconds with the camcorder or camera on the top, and that gives you, you know, the steadier ride. I find that it still pendulums a little bit, and you saw that in the videos. You know, you still got to control it a little bit at the beginning and end of your movements, but you know, it's not perfect. I don't think that the ones that you pay $500 or $600 for probably work that much better. I mean, I'm sure that if I get one that costs $10,000, it would work, yeah, a lot better. But compared to the designs that you just carry around like this, even if it's a glide cam style or whatever, I have a feeling that it's mostly learning to use it the right way, getting really good at it, not so much the design of the stabilizer itself. So if you want to save yourself some money, have fun, make a fun project, try and make one yourself. I encourage it. I found it pretty rewarding. It was cool to kind of learn about the design and what goes behind it, and come up with my own idea and see it come to fruition. So good luck, and happy videoing, right? Bye-bye.